Exponential. Today I want to talk about the graphs of the logarithms. So we already know there's a relationship. Let's see that on the graph. If I want to graph y equals 2 to the x power, okay, we graphed those on our last test. What did we have to do? Plugged in -1, 0, and 1. So 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the first is 2.
Might be raining.
Just a little bit. Is it supposed to quit before the track meet today? I didn't really think it was supposed to rain that much today.
Well, it's supposed to, I seen where it's supposed to rain.
Unfortunately, it rains every day, or just every other day.
Making up for all the rain that we didn't get last summer, right? That's how it works.
If only we could board off.
That would help. Okay, so that was our exponential. Remember, the exponentials always had a horizontal asymptote. We can see it's approaching the x-axis but not crossing it. If I did the domain of this one, my x's can be anything. My range is just above 0 because of that horizontal asymptote. Now let's look at the log. So if I asked you to graph y equals log base 2 of x, let's put that in exponential form. That means 2 to the y power equals x. So isn't this really just another exponential? When we graphed exponentials, we plugged in -1, 0, and 1 for the exponent. Which variable is the exponent? Y. So my y would be my -1, 0, and 1 this time. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. So if I graph this, I have the points 1/2, -1, 1, 0, 2, 1. Graph's just getting closer to the y-axis. What's the relationship between these things? Yeah, so the asymptotes, there's a connection there, but these are inverses, because if you look at the ordered pairs, didn't x and y just flip spots? Our asymptotes are related. The exponential has a horizontal asymptote at 0. The log has a vertical asymptote at 0, because they are related. So exponentials have a horizontal, and when you do the inverse, x and y flip, so that becomes a vertical. The domain of the log, I already told you it was just positives, but we see it's just 0 to infinity because that was the range of the exponential. The range of the log, this one's going down and up forever, negative infinity, positive infinity, because the x and y is just flipped. So exponentials and logs are inverses of one another. To graph our logs, we are always just going to change them into exponential form and graph them like we did our exponentials. But this time when we're putting in our -1, 0, and 1, it will go in for the y, because that is the exponent. Any questions on that? So let's graph this one. F of x equals log base 1/3 of x. So if I'm going to graph it, we need to rewrite it. F of x is the same as what variable? Y. And to change it to exponential, your definition, this would be 1/3 to the y power equals x. So my t-chart, y is the exponent, so that's where I'm plugging in -1, 0, and 1. What is 1/3 to the -1? One-third to the 0 and 1/3 to the first. It's 1/3. Almost positive. 3 -1, 1 0. 1/3 1. These always have a vertical asymptote. It's getting closer to the axis, but you can't cross it. So it looks like that. Exponentials have horizontal asymptotes. Logs have vertical asymptotes. Questions there? Let's do a couple of transformations. So we are going to graph each of these. Just like when we were graphing exponentials, what I typically had you do is the parent function first. So my parent function here would be what? Log base 3 of x, just your typical log. Okay, so if I graph that, 3 to the y equals x. Make your t-chart -1, 0, and 1 for the exponent, which is my y. Plugging those in for x. Or to get my x, so 3 to the -1 is 1/3. 3 to the 0 is 1, 3 to the first is 3. 1, 1, 0, and 3, 1. It's my parent function, so I'm going to make it dashed. If I'm trying to graph log base 3 of x plus 2, what would the plus 2 do to my graph? If I move this log left or right, what else gets moved? Because it's a vertical asymptote, that's going to move when you go left and right. So I'm going to draw in my vertical asymptote is now at -2. And then I just move each of my points to the left. Alright, what would be the domain of that one? Doesn't equal -2, so it's parentheses, keeps going forever after that. What's my range?
So could there be a horizontal asymptote, like, where they basically just
Not on a log. It will always keep going up. It's slowing down, but it will always keep going up.
I just didn't know if they maybe just couldn't see the
Yeah,
asymptotes, so
It-
who knows there.
yeah, there isn't a horizontal one. It is flattening out as you go, but it's still going to continue to gradually rise. So that's a good question. Alright. Why don't you guys try B? Graph your parent function. So the parent function is log base 4 of x, which means 4 to the y equals x. You make your t-chart, you get 1/4, -1, 1, 0, and 4, 1. So graph those. One, 0. I made my points too far apart. Did everybody get your parent function correct? What's my transformation? Up to. So if you move each of those points up 2, does that move my asymptote? No, it's a vertical asymptote, so it's only going to move if we go left or right. And since we didn't, it's still just right here. What's my domain? My range? Very positive infinity always. Alright. Let's do one more. What if I said log base y equals log base 4 of negative x? So log base 4, that's the same parent function we just graphed, right? So our points we had 1/4, -1, 1, 0, and 4, 1 from the previous example. What does a negative on the x do? Reflect it over what? If it's out in front, it's making your y's negative, so it flips it over the x. If it's on the x's, it's changing the signs of your x, so it flips it over the y. So if I move each of these points over the y-axis, it's going to look like that. Asymptote didn't move. On a log, the asymptote will only move if you move your graph left or right. What is the domain of this one? And range every time it's negative infinity to positive. All right. Any questions on these graphs? Do we need more examples with graphs? The final thing I want to talk about is finding the domain if we don't draw the graph. Like, how can I just look at this equation and know what my domain will be? And we've kind of mentioned it before. I told you in a log, the argument always has to be positive. So that means negative x has to be greater than 0. If you divide by -1, that means x is less than 0, which is the negative infinity to 0. So if I'm asking you to find the domain of a log, we really just have to take the argument greater than 0 and solve it. So let's try a couple of those. So if I want the domain of this, my argument, x minus 1, has to be greater than 0. So that means x is greater than 1. How do we write that in interval notation?
One, two,
Yeah, it's bigger than 1, so 1 to
because if the x is on the left side, like it normally would be, it's just whatever way that arrow is pointing.
On B, does the minus 1 on the end change anything? No, that's going to move my graph up or down. It doesn't change the x's. You're just doing your argument greater than 0. So what's my domain?
Greater than negative
0 to infinity. X is greater than 1. And make sure when you're solving those, if you do multiply or divide by a negative, you flip your inequalities. Alright, if we look at C, this one's a little bit different. I want to know when the absolute value of x is greater than 0. There's different ways you could do this, but one way is just kind of thinking back to what we know about the absolute value. In chapter 2, we graphed all these parent functions and transformations. What does an absolute value look like? It's a v. Absolute value of 0 is 0. 1, 1. 2, 2. Negative 1, 1. Negative 2, 2. Remember? Can you tell me when that is greater than 0? Always, except at what number? 0. Because at 0, it's equal to 0. And I don't have an equal to on this. So on this one, my domain is everything except 0. Everything is 0 union 0 to infinity. Alright, D. X squared minus 4 has to be greater than 0. So we can do this one a couple different ways. We talked about quadratic inequalities. Remember we made sign lines for those? So I'd throw in some problems that would make us think back. You could also look at a graph on that, so that's completely up to you. X squared minus 4 would factor into x plus 2, x minus 2. Remember when we were trying to decide when this is greater than 0, we found out when it was equal to 0. X plus 2 equals 0, that is at negative 2. If x minus 2 is equal to 0, that is positive 2. Do you guys remember picking test points from here? So we would do things smaller than negative 2, so maybe a negative 3. In between them, so maybe a 0, bigger than 2, maybe a 3. And we're just plugging them in to see if we get a positive or a negative. So if I put in negative 3 plus 2 is negative, negative 3 minus 2 is negative. If you multiply two negatives, you get positive. Put in 0, 0 plus 2 is positive, 0 minus 2 is negative. Positive times a negative is negative. Put in 3, 3 plus 2 is positive, 3 minus 2 is positive. Two positives make a positive. Which ones did I want here? Greater than 0 says the positives. No equal to, so everything's parentheses. So negative infinity to negative 2.
You don't have to do that like negative 2 and 2.
Right, because
You don't
those
have
are
to do a
negative.
third union or whatever.
Right. If this had been a positive in the middle too, then you would have. But we only wanted the positives, not the negatives. All right. So we talked about the graphs and we talked about the domains. I have more examples. Do we need more practice with either of those things? if you look on Google Classroom, I posted a handout, so you have the hour to work on that and ask questions.